Well, hello, ladies and gentlemen. I know you see the document camera right there. Hey, I'll be right back. I gotta go grab something in the hall. So give me 1 second. All right, let's see who's here. Ruben's here. Mariana's here. Hello, hello. Good morning. Hold on, let me get live here. Here we go. Good morning, ladies and gentlemen. Let's do a little roll call. Good morning, ladies and gentlemen. All right, let's give everybody a chance to get here. In fact, to help facilitate that, let me hold on. I don't know if I posted. I had a little problem with the link. I had it all set up yesterday, and it wasn't quite working. So now I got it. Now I got it. Do a little roll call. So let me post a link to this in our Google Classroom so that those so everybody can find it. All right. So we should be okay now. Paula's here. Good morning, Paula. Yeah. Hey, Haley. How are you doing today, Haley? You woke up a little late today. That's all right. It happens. So, Haley, we had some technical difficulties yesterday with the freshman classes. I had really bad problems with my internet all day, and so all we did yesterday was do the review, and then today, what you guys are going to do, I posted in your Google Classroom, so it's there right now. You're free to hang out here. We're going to start reviewing some stuff, but it might be a little beyond where you're at. But yeah, I'm glad you're up and about. Let's see here, Paula. How did you take the news from yesterday? Let me know. Leave me a comment, or if you want, you can send me an email. Quite a few of you guys sent me emails last night about how you were feeling, and it was good to hear. A lot of you guys have your heads on straight, so that's good. Hey, Chris. Good morning. Oh, today's record, Ruben, is Pink Floyd. Hold on. Let me find it. Let me go see. Let me go grab it right here. Oops, sorry. Pink Floyd. This is what I'm listening to today, Ruben. Where I was listening today. It's a Pink Floyd album. It's not one of their most popular ones, but I really, really like it. I think it's a great album. It's kind of really mellow. Sasha's here. Hey, good morning, Sasha. Leah's here. Yesenia's here. Crespo's here. Davy Boy says, freshmen supposed to watch this. You're absolutely welcome to. Davy Boy, you are absolutely welcome to. I put an announcement about some updates with Cambridge for you freshmen. Posted the link in your classroom. And also have your work there. But you can hang out here and kind of see if you can follow along. Especially if you were here yesterday and did what we did yesterday, then you're going to be quite all right. Ale's here, Danitza's here. Good morning, one and all. So we have quite a few people here good already. That's great. That's great. Omar Lopez is here. Angela's here. Yeah. Oh yeah, I agree with you, Ruben. They're pretty interesting, kind of creative, right? Well, not kind of, very, very unique. Got my coffee going, although I've actually been really busy, so it's kind of cold already. Makes me sad. All right, now we got a little buffering going on. I don't know why. I shouldn't, because it says that streaming speed's good, but it'll clear up. Hector's here. Yesenia's like, I don't get yesterday's homework at all. Yeah, that's why we're going to do the review today. You'll get it, okay? So hopefully today we'll get it, and if not, you have to let me know. Paula says she was expecting the news. Yeah, I know. Doesn't make it any less disappointing. When when I heard like just the news, I was devastated. Well, devastated might be dramatic, but I was really upset. It definitely wrecked my day. Yeah. Mariana. Yeah, Hector's on time today. Look at that. Hey, public service announcement here. Listen, if your parents are home because their work is closed, they're probably going a little stir crazy. Everybody's going a little stir crazy. One of the things that's easy to do for everybody, regardless of age, when you're feeling stressed, it's easy to just focus on your own feelings and your own level of stress instead of considering how other people are feeling because they're feeling equally stressed. And so, if you keep in mind that people are acting stressed, and sometimes when we're stressed, some I don't know, unflattering behaviors come out. And if you just keep that in mind, you could be maybe a little gracious, be a little patient, give people their personal space, allow them to make mistakes and do things they shouldn't maybe necessarily do without reacting, because you know we all mess up. So let's see here. So I'm just reading through the notes or through the chat messages. Yeah. Um, Mariana, did you really burn down your kitchen, Mariana? Like you said it the other day, but I thought you were joking. Come on, you got to be joking, right? You're not going to be stuck eating cereal from now on, are you? All right. So, let's see how long we've been here. So yeah, we've been here plenty of time. That I think whoever's here is here. So let's go ahead and get to today's lesson, shall we? We were talking about transformations of functions, right? And let's go ahead and switch over to the document camera here. So look, hold on. Get my sorry, got all my crap in the way here. I got stuff everywhere. It looks like my desk at work now instead of my desk at home. Usually my desk at home is super neat. All right, so look, the thing we were talking about yesterday here. Let's just review some of the basics before we start getting into the homework, right? So if we have a function, like that's generic, right? Like we could have all kinds of numbers there. Let's see. Angela Acosta's here. Good morning. Good morning. Yeah, Paula, I agree. I agree. Paula says that focusing on what's coming up is really helping her deal with it. And I think that's a good idea. Just focus on what you're in control of. All right, so now, check this out. This is what we learned yesterday. We have a function like this, right? What we learned is that the exponent will tell you the shape, right? And you don't know a lot of those yet, but it doesn't really matter. So, like the way that Cambridge asks these questions, and we're going to see one of those today, you don't even need to know what shape it makes, okay? Um, you just you know that it makes a shape. So you know that if it's here's the deal though. I'll go ahead and tell you this. If n is even, then it's going to look the ends are going to look like this or like this. Now some things could happen in the middle. Like this would be quadratic. But, it could go like this. Oops, sorry. That's for n is odd. Sorry. It could go like this. Kind of like a weird looking W, right? And that could be flipped over as well. That could go down. So it could be something like that, right? That's for n being even. And I know you don't understand why, but for now, you just have to trust me, because it doesn't really matter what the shape is. What really matters for us right now is how A, H, and K move it. But let's go ahead and continue. I'll give you the information later. We'll learn why. Okay, if it's odd, it's going to look something like this. Like that's a cubic, right? And a cubic could also look like this, right? But there could be more things going on in there. But here's the deal. If it's odd, it goes from left to right. It's either going to go up or it's going to go down. Like even, they go like it's going down and then up. So we kind of look at it, it looks like it's going up both ways or down both ways. But technically, you read a graph from left to right. This is going up over, or this is going down over here, sorry, and it's going up over here. Because even though the arrow's pointing that way, that shows that the line keeps going that way. But you read a graph from left to right, so here it's going down, it flattens out and starts going up, you see? So even ones will go down one direction, up the other. odds will either be going up both directions, like these are all going up both directions, or it'll go down both directions like this. But once again, doesn't really matter. Yesenia wants to know, hey Vanessa, good morning. Yesenia wants to know what's shape. So like the shape, Yesenia, you know how like if you have, say y equals x squared minus 9, that's a quadratic, and the shape is a parabola, right? If you have y equals 3x minus 2, the shape is a line. If you have y equals x cubed, we've seen a few of these, the shape, it's called cubic, it's like that. Do you see? Yeah, so that's what we're talking about with shape. Does that make sense? Let me know. I know it's kind of weird, there's a 30-second gap between what I'm saying now and when you hear it, and then I also have to pop up and look over at the questions or comments in the chat room, but let me know. Yeah, right. So Leah's explaining there. Okay, good. Excuse me. All right, so now don't worry about the shape too much, because the reason that you don't have to worry about the shape too much right now is because we're going to give you the graph. What you need to understand from yesterday is this. This is the part you've got to understand. You have to understand that A does two things for you. It changes direction and it changes width. What it really does is it does a vertical stretch. That's really what it does. So this is what it looks like. It looks like it changes the width. Boy, my handwriting is really ugly right there. But what it's really doing is it's doing a vertical stretch, right? So just an example of that, and we did this on Desmos. We can do it again today too. So if this was f of x, right? If we had 2 f of x, then what would end up happening is it would look skinnier. But all that's really happening is like this coordinate right here, you know how that's like an x and a y? Well, this x coordinate right there, this would be x and 2y. It just doubles it. Good to go? Desolation Dawn. Who's Desolation Dawn? Is that Dominic? Who is that? Oh, good morning, whoever you are. That's probably Dominic, right? I haven't seen, I don't think I've seen you in one of the chats yet today, but I'm glad you're here this morning. It's good to go. All right. So, Yesenia, let me know if the A makes sense. All of you guys, let me know if A makes sense, and we'll review H and K right here. So, A is the really confusing one. H isn't so bad. H is a shift, like a translation. And it's left or right. So, it's horizontal, right? It's horizontal. And the only thing that's tricky about it is that it's the opposite direction of whatever number you see right there. So if it was if you had plus 5 here, you would go left 5. If it was a negative 6, you go right 6, right? And then we talked about. So if that doesn't make sense to you guys, let me know. Let me know before we go over the homework. We'll go over that again. We'll give you some examples, right? And K is a shift, but it does up or down. I should probably done that up and down, right? And it's vertical. It's not opposite, it's just whatever the number is. Do you see? Yeah. So you guys let me know if we're good right there. Yes, that's right, Yesenia. F of x, same thing as y. F of x is the same exact thing as y. So x is the input, f of x is the output, right? Yeah. That's good. It's a good question. Okay. I don't know if you guys can hear my wife's parrot down there whistling, making all kinds of racket. I don't know why he's all bajiggity today, but he is. So here's what we're going to do. We're going to go over to Desmos real quick, all right? So here's Desmos for us. And I will try to do better today with switching between all of these things today. Like I've got 3 different feeds, but I only have 2 screens, and I need to watch like what's happening. So I'll try to do a little better right here. Okay, so check this out. Let's say f of x equaled. Let's do 1. Let's do x minus x minus 0. So this is our generic one, right? This will just give us the shape. And let's do an exponent of, what do you guys want to do? 6? 5? 5. Let's do 5. And then plus 0. That looks cubic, right? But it's not, because like here's what cubic would look like. It's really similar. Do you see? Cubic is not quite as flat in the middle. There's a bunch of stuff that's weird about some of these polynomial equations, and we'll get into them in detail in the future, okay? So, let me just get caught up on the questions here with you guys, okay? So, let's see here. A couple questions. So, in the case graph turns sideways. So, in this case, could the graph be turned sideways? So, functions will always have one input and one output. So, it's not really going to turn sideways. Yeah, not the pug, Ruben. It's the bird. It is a little confusing, Johnny, and I hope we get some clarity with that today. Yeah. Oh, yeah, no, not the pug. It's the bird. Okay, so I got your questions there. Let's get back to let's get back to this, right? So here's the deal. Here's the deal. We got this graph right here, right? Hold on, let me see if I can do it this way so I can keep track of, right? And this is the shape that x to the 5th would make. So now, if we add in some numbers for this, for a, h, or k, then we can see how the graph changes, right? All right, so now we'll do a first. A just changes. It's a vertical stretch. So like, if it's a 2, then what it does is it takes each output and multiplies by 2. So this point doesn't change because the output is 0. Oops. This point doesn't change because the output is 0. 0 times 2 is just 0, right? But like here at 1, right? 1, we have 1. What do we have? I think we have 1, 1, right? So instead of 1, 1, it gets multiplied by 2, so it's going to be 1, 2. Do you see? Yeah. Just like we talked about. So if that seems like redundant and review from yesterday, just be patient. I know it's some of you guys got it. Some of you guys got it and then you're going to forget it. Some of you guys never got it in the first place and maybe you're going to get it now, and that's okay. All right, now. So we see what the 2 does. The 2 it's a vertical stretch. If 2's negative, it flips it over. Do you see? So if 2's negative, it flips it over. Right. All right, let's leave A1 for now. Now, let's take a look at what H does, because H is going to be the number inside the parentheses. H does a slide left or right. Do you see? All right, so let me before we get into H, I got a couple questions about A. So the greater the exponent, yeah, that's true, Madiana. Like the bigger the exponent, the flatter it's going to kind of be right in here. Also, there's other things that happen too. They're not really, I don't know. It's hard to introduce new information like this because, like, it's at the very beginning. So there's a lot of stuff you guys don't know. And that's like the biggest difference between where you guys are now and where you guys were at the beginning of your freshman year. You never wondered. You just expected me to tell you, and whatever I told you, you had to understand, and you were good. But now you're wondering. That's why you guys are doing killer. All right. So keep asking those questions. But unfortunately, to explain all of that, it's going to take a little while. So we're not going to get into it today. All right, now Yesenia's question is, the greater A is, does that mean the graph becomes narrower? That's right. So when A, so let's just make sure. So like if A is 5, it's even narrower, right? And if A was 11, even narrower. And if A was 50, even narrower. Do you see? All right. Yeah, George, no worries. No worries, George. I'm glad you're here. Whereas Yesenia, if it was a fraction, it gets flatter. Do you see? So let's say this is going to be 1 over 11. Oops. And let's say this is 1 over 50. Do you see? So the flatter, like here, we can get rid of these. So the flatter, like here, 1/5, the flatter the graph is, that comes from a fraction. Negative flips it upside down, just like before, right? But the flatter it is, or the when you have a fraction, it gets flatter. When you have a whole number, the bigger the whole number, like the steeper it gets. So if we had 27, do you see? All right, good to go. How flat would it be if it was a fraction of 1 over 1,000? Pretty flat, but not as much as you'd think. because when you have the power of 5, numbers get really, really big at the power of 5. So like when we plug in, say, 4, when you plug in a 4, right? 4 to the power of 5 is a pretty big number. I don't know off the top of my head what it is. 64 times 16, whatever that is, that's a pretty big number. That's right. That's right. So Yesenia says she's good. That makes me very happy. Hey, Manny, good morning. Paula says cubics are not as flat compared to when the exponents get bigger. That's absolutely correct. And one of the other things I wanted to show you guys is what happens, like, let's change this to a 7. Do you see? It's still kind of the same shape, but it's going to get flatter and flatter the larger it is. So that looks really funky right there. It's not a bend. It is curved, I promise. But yeah, and that's really interesting. There's some reasons why this looks like that. It's kind of we'll have to get into that later though. Okay, but here's what I wanted you to see. Notice every one of those numbers I plugged in for an exponent, they were all odd and they kept the same shape. Whereas if it was even, it's going to look like a U. It's going to go up both directions, and if it's negative, it goes down, right? And that's misleading because here we're actually increasing. Like you can look at the y's, we're actually increasing, and here we're getting kind of almost flat. And then here we're decreasing, but yeah, so that's good. That's good. You guys have some good questions right there. Let's change this back to 5. That's right. So Ruben, the higher the exponent, the flatter the middle gets. But that's when it's in this form. There's other forms that you're going to have, like local minimums and maximums and all kinds of stuff. Those are great questions. Okay, so I think we're good right now on what A does. So now let's talk about H. H just slides things left or right. So right now in red is the only graph that's showing is, our generic x to the power of 5. Where A is 1, H is 0, K is 0. So we're going to change this to 4. And then what's going to happen, you see how it says minus 4? That means this point right here and every other point is going to be moved over 4 places. Like visually, that's what happens. Yeah. Will you ever have to find n? That's a good question, Yesenia. There are that's tricky. There are clues to be able to figure out what n is, and it's really not that difficult once I show you guys all of it. Now, sometimes you can't actually tell right away. You'd have to do some investigation, but no, typically you're not going to be given a graph and asked, what would the exponent be? You would be asked, like, can you give me some clues about the exponent, like some possibilities? But no, you're not really going to be asked that. All right, so both A and the, yes, that's right, Mariana. Both A and the exponent kind of affect that middle section. So here, when we changed H, we went the opposite sign as a horizontal shift. And we could see how that works with by exploring with a T-chart. But for right now, I think just understanding that that's how it works is fine. Now, if we did a plus 4, it goes the other direction. It goes to the left 4. So it's the opposite sign. And I think you guys are okay with that too. It's A is the confusing one. And what K does is K moves the whole thing up or down by whatever the number is. Do you see? Right. Yeah. So that's how those work. That's exactly right. So Yesenia, if H is negative, the graph moves right. If H is positive, the graph moves left. Exactly. So check this out. Let's put some, here's what we're going to do. Here's what we're going to do. What I've got now on the screen is I've got an example where I changed K, an example where I changed A, and an example where I changed H. So we're going to see how all those look, and we're going to do all of them at once. So we're good. This one is right here is a vertical shift by 1, right? So every single point moves up 1. Every single point moves up 1. So whatever the output is, it's plus 1. Whatever the output is, plus 1. Like here, the output is 1 when input was 1, so now the output is 2 when the input is 1. And like right here, the output is 3 at, like, what is it? It's 3 at 1 point. I can't quite get it. 24 something, right? So on the other one, at 1.24 something, it's going to be 4. So let's see, 1.24 something. Oh man, I lost it. Oh, they're on the wrong graph. There we go. That's why. 1.24 something, and we're at 4. Do you see? Every single output has 1 added to it. Yeah. Now here the outputs get doubled, and we know what that looks like. Every output gets doubled, so it just goes up faster. It looks skinnier, right? And if this was a fraction, it would look flatter. Now, this one moves it to the right. Do you see? And we could do all of those together at the same time. We could do a 2, a -2, and a +1 all at once. So let's take a look. Let's see if we can make sense of this, right? Let's go ahead and, no, I can't quite highlight it. Here, I'll do it like this. I know how to do it. 2, 1. And we'll label that. And we'll also label the other one that's at the origin to help us see. Okay? All right, so from this one to this one. Alicia is here. Hey, good morning, Alicia. How are you? So from this generic one, x to the 5th, to this one right here, the 2 makes it go up faster, so it's narrower. So even though they're not overlaid, this one does go up twice as fast as this one does. The -2 here moves everything to the right 2, and the 1 moves everything up 1. So the 2 makes it skinnier, and these two, the -2 here and the +1, those shift it. So like if you did oh, I just lost the word. If you did that as a transformation as a vector, it would be a 2 over a 1, right? So x is 2 and y is 1. Remember? All right, so that's what we covered yesterday. Now let's see if our homework will make sense. Let me switch some things around here. Let's see here. There we go. So that's what we kind of covered yesterday. So now let's see how our homework's doing. So let's get into this one right here. All right, here. So what I did yesterday is I gave you a generic graph, like say this is f of x equals x cubed. You didn't really need to know it was x cubed, right? Oh no, that was notes. So I gave you a generic graph, right, like f of x right here, and I asked you to do this transformation. Do you see? And you're just going to kind of sketch it. So this is kind of strange to do like virtually. In person, this would make a lot of sense. Like we could kind of go over it and I could give you immediate feedback. So we'll just have to, we're going to have to do our best with this part. This is going to be a little tricky right now, but we'll get there, right? We'll get there. So this is our graph f of x. And what we're going to do is we're going to multiply it by 3, which is going to definitely make it narrower. And it's going to be shifted. It's going to be shifted, like if we did a column vector, this would be the column vector, right? It's going to be x is going to be moved to the left 2, and y is going to go down 1. So what we're really going to do is we're going to go 2 and 1. So we're going to go -2 that way, and then we're going to go -1 for each and every point. We don't know what each and every coordinate is, so all we're going to do is use this center point right here. This it's not really a center point, but you get the idea. So what we're going to do is we're going to go, let's say that's 1, let's say that's 2, and let's say that's 1. So this point right here is going to be like over here somewhere now. Do you follow me? And it's going to be the same shape, but it's going to be steeper. So I have to try to make it look narrower by a stretch of 3. So I'd say if you did that's pretty good. That's for the first one, right? How'd you guys do on that? Let me know if you have questions. And then if we can't answer the questions here, then I guess what we'll have to do, we got a couple options. You can email me a picture of it, or we can do a Google Hangout, and you guys can just show me on your cameras. I know we haven't been doing Google Hangout because a lot of you don't have web cameras, and also it's harder to record and make it available to people in the future, and it's also even blurrier than this. All right, so you guys let me know how you're doing with that one. So what are you confused by, Yesenia? Yesenia says she's confused. So here's what I'm going to do because there's a lag, right? So here's what I'm going to do while there's a lag. because there's a leg, and I want to hear why Yesenia is confused. What I'm going to do is I'm going to redraw number one on a fresh piece of paper and try to make it a little cleaner, right? And no, I know what we're going to do. We're going to do it on. I know what we're going to do. Yeah, we'll do it. We'll do it on paper, and then we'll do it on. I'll do both my ideas. We'll do it on paper, and then we'll do it on Desmos. Okay, so that's what I'm gonna do while I'm waiting for explanation. So here's what number one looked like. Whoa, number one, the graph looked like this, right? And so we're saying like this is the parent function. Now let's say there's a like let's say that's f of x, right? F of x equals y. But so now let's say that f of x equals the same f of x. Let's say the same function equals, what was it, 3x plus 2 to the power of n minus 1. So what we're being asked to do is we're being asked to redraw this with that transformation. Okay, let me get to a question. We got a question now. What are those two? Oh, all right. So Yesenia wants to know, what are these two equations for? So check this out. These are going to be transformations of this graph. So this is like the generic graph. We don't actually know what its formula is. Like it looks kind of like it could be x cubed. We don't know for sure. But this is the equation we're going to have to transform with this a, h, and k. That makes sense? And then, so like this is like the instructions. What we have to do is we have to redraw this graph with this transformation. Then we have to redraw this graph with this transformation. Yeah, so like for example, you see, you remember how when we did it on Desmos and like I would plug in like 1x minus 0 cubed plus 1? And then I would change these. So like in another one, I would do 3x plus 2 cubed minus 1. It's kind of like the same thing, except we have to draw it instead of seeing how Desmos would do it for us, right? So here's what I know. I know that this 2 means we're going left by 2, so it's a negative 2, right? And this 1 means we're then going to go down 1, right? So we're going left 2 and down 1. So this point right here is going to be left 2. Left 2, so let's say that's 1, let's say that's 2, let's say that's 1. So it's going to be over here. This point is going to be here. Yeah? And I know that because of these two numbers. And now I just got to take care of the 3. The 3 means it's going to be narrower. So like one thing I can kind of do is if I try to like make it look the same, right? Then I can kind of try to make it narrower basing it off of that. Do you see? And so I can go ahead back and I can erase this. That gave me a clue of how it's going to look. Yeah, let me know. Does that make sense to you guys? I appreciate you guys being patient. I know it's got to be frustrating, being confused, and hard. It's hard to get good clarification. It takes a long time with this kind of format compared to like, you getting to see my beautiful face in person. Yeah. All right. So that's what the first one was. Now the second one, we had to do the same exact graph, but we had a different transformation, right? So for the second one, we had to do this graph again, but the transformation now is negative x to the power of n plus 3, right? Okay, so negative x to the power of n. Do you guys know why the negative's on the outside instead of the inside? So like, check this out. If n is negative, then these two things are the same. That's if n is odd. But if n is even, then these two things are not the same. You guys know that? Okay. I know, Johnny, I am quite lovely. My mom thinks so anyway. Vanya, hey, good morning, Vanya. How are you doing? So Vanya wants to know, how do I know that this is going to be narrower because of that 3? because what ends up happening is this 3 does like does a stretch, a vertical stretch. So it makes everything go up by 3. So like, for example, if we overlay 2 of them, and let's do quadratics because we can do a quadratic really easy. So let's say this is x squared, and for x squared, you know, for x squared you have the point 2 comma 4, right? Because if x is 2, you plug in 2, you get 4, right? So if we did 3x squared, watch what happens when you plug in a 2, right? That's 4, which is 12. So the output got multiplied by 3. So at 2, instead of being at 2, 4, it would be at 2, 12. We'd have a point 2 comma 12. And so in every point that would happen, every output would be multiplied by 3. So what ends up happening is it ends up looking narrower, it ends up looking skinnier, but what's happening is growing up faster. Yeah. Oh, I'm great. I'm great, Vanya. Thanks for asking. Yeah. Does that answer your question? Let me know. I'm happy to come back to it if we need to. Okay. Same with your question, Yesenia. If I've answered your question on the question on this problem, then let me know. Or if I haven't, definitely let me know. Okay. So let's do this one now, right? So we'll do this one in greenish blue, this color, right? So this right here, here's what I know. Here, if you look, H is 0. So this isn't going to be shifted left or right. It's only going to be shifted up and down. So I know for sure it's going to be up 3 because that's what K is, right? So it's going to be up 1, 2, 3. So it's like this point will be up there. So it doesn't move left or right, just up or down because of this. And this negative means it's going to go down. It's going to get flipped over. So instead of looking like, so it's going to look like that. It's going to look like that instead of like this. It should be the same width. It's hand drawn, so it's kind of ugly, right? Good. I'm glad you're solid now, Vanya. So it's hand drawn. It's kind of ugly. We could like make up numbers and plug those in on Desmos, and maybe we should do that just to make sure. Okay, so check this out. Let me get to Desmos here. Here's Desmos. Hey, buddy, we missed you. All right, so check this out. Our first graph, it looks kind of like it could be an x cubed, right? It's anything to an odd number. So let's do x to the 7th because we haven't done one, right? So x to the 7th, that kind of looks like our original. No, sorry. That kind of looks like our original graph right here. It kind of looks like it. Not entirely, but this kind of looks like that. It probably is more close to x to the power of 3, but it doesn't really matter. Because what I'm trying to show you is how you could kind of just plug in some numbers in Desmos to try to help you out, right? So now, here's what we need to do. We need to change x to the 7th so it looks like this. So I'm going to plug in a new equation in Desmos, and I'm going to say 3x plus 2, and then I need to do an exponent of 7, so exponent 7, and then minus 1. Do you see? So this point right here was right here. So look, it's 0, 0, and now it went left 1, 2, and down 1, so our point was right there. Do you see? And it kind of looks narrower, but it's kind of hard to tell. So what we can do, if we want, we could do this, 3x to the power of 7. And you can see, yes, it is narrower. It's not a ton narrower for 7, but yeah, it is. It is narrower. So that's how you can kind of use Desmos to help you out. All right, let me see what kind of questions and comments we got now. Oh, good. I think we're good. All right, so let's move on to the second one. We'll go ahead and do it because we'll go ahead and do it on a separate piece of paper, shall we? Hold on, I got some issues here. Hold on, let me get my computer reset up so I make sure I see what you guys are seeing. Okay, now I see what you guys are seeing. So let's go ahead and do this last one. So in this last one, here's what we got. I gave you a point, and I said that point was 4, 3. And I said this was our function. Oh, that's really ugly. Now it's beautiful. Like all of you, especially you, Johnny. Right? So there we go. So we have this one right here, and this is our generic function g of x, right? And we're gonna map a transformation. We're gonna do a transformation of this. So we're gonna say now we're gonna say what would this look like if instead of just being the output being the same, what if instead it was 1/3 x to the power of n plus 1? Do you see? And I hope you guys have a pretty good idea how to do that now. This plus 1 means the whole thing is going to move up one spot, right? So instead of being 4/3, that plus 1 is going to make it at 4/4. You see what I mean? It just moves it up 1. Every single point on here is going to be moved up 1. But the 1/3 is kind of tricky because it's going to make it flatter. So instead of being kind of like mirroring it, it's going to be kind of flatter. So it's going to look like this. You see? This is kind of like a quadratic, kind of. Yeah. Oh, Johnny, I'm sorry, Johnny. You got to learn how to take a compliment. You shouldn't be blushing. It's quite all right. Truth, there's no need to be embarrassed about. There's no need to be embarrassed about the truth, Johnny. All right. Okay. So that's that one. If you guys have questions on this one, we'll call it number 1. If you guys have questions on number 1 for this part, hey, just let me know in the comment. I know I don't sound like a broken record, but that 30-second delay does make it kind of strange, and you might feel like I'm just moving on without considering your questions, but I'm not. I'll go back. So now, next one. We had to do -2x plus 3 to the power of n. All right. So I see what you did there. So we'll do this one in, we'll try this one in green. Got all these fancy these pens at home, but they were never used, but they're so old the ink doesn't flow very well. So let's try this one, right? Here's what I know. This one's not going to move up or down because there's nothing at the end, so it's like a +0, right? So, but this 3 right here means we're going to the left 3 spots. So instead of this point being at 4/3, it's going to be at 4/0. Do you see how I knew that? Yeah. And then the 2 means that instead of being flat like this, it's going to be narrow. It's going to be narrower. It's going to go up twice as fast. So like let's say this was a 0 also, and it was just twice. Whatever this number is here, it would be twice as high. Everything would go up twice as fast. So it's going to look something like that. Yeah. So same general shape, but like narrower because it's going up faster. How are you guys doing with this? Oh, you know what? When I copied this question, I actually copied it wrong. Look what I did. It's supposed to be a -2. Uh-oh. I have no idea. You think it's important? Might be a telemarketer.
Our records show that your vehicle warranty has expired or is about to expire.
Wow.
This is your final courtesy call, as you should
It's
have
very
received
courteous.
mail.
Oh, we
Press
should have.
5 be connected to a warranty specialist.
How about block? All right, sorry about that. I thought it was kind of funny. Actually, I had to answer the phone because there's some stuff going on. I just want to make sure it was available. So Johnny wants to know how I got 4,0. Before we talk about that, I want to talk about that warranty. You heard they say that my warranty is about to expire. Do you guys know how old the vehicle I drive every day is? There's 2 I drive. I actually own 3, me personally. My wife has a new car. It's a 2017, right? I know, right, Reuben? Reuben's gotten that call. My truck is a 1969 Chevy, so the warranty's about to expire. Whoa. And then my 4Runner's a 1992, and then I have a little Celica that's a 1994. I think the warranties are expired. I'm the warranty. I gotta fix them. All right. I know, right? Repossessing that car was great. I'm still in possession of that car. We're trying to, the owner's going to sell it. But with all of this coronavirus stuff and whatever, it's not going to happen for a little while. So it's just sitting there. So now let's get to Johnny's question, shall we? Johnny wanted to know on this graph, how did I get 4-0? 4-0. This one right here. And before I answer his question, I want to make sure, and I know some of you guys caught this and you probably got a different answer, and maybe you don't get it, didn't see why. I didn't copy it correct. It says -2. So we'll address that in just a minute, okay? So Johnny, here's how I got 4-0. Do you see this 3? It's that's what H is, right? So that means it's going to go the opposite direction 3 places. So this point is going to go 1, 2, 3 places over. So if it started at 3, oh, Johnny, hold on, Johnny, that's totally wrong. Ah, I can't believe I did that. Look, that's silly. Oh my gosh, what was I thinking? Oh, I know what I was thinking. Oh, I hate myself. That's totally wrong. Oh, here's where it should be. Oh my gosh, Johnny, it should be right here, and the coordinate should be 1, 3. Johnny, I am so sorry. And the graphic will look the same like that. Wow, Johnny, I didn't even do that on purpose. I swear, that was a total accident. Here's what I did. I just wasn't being careful. I saw the 3. I saw a 3. I'm like, oh, that's convenient. And then I screwed it up. Man, that's all that happened. And that happens a lot. I know I do it, and I know a lot of you guys do it too. So again, just to be sure, here's what happened. The reason I said 4-0 is 4-0 wouldn't even be there. 4-0 would be like here. Oh, wow. So the reason I did 4-0 is I knew we were moving left 3. I saw this 3. Left, this one's left and right. This one's up and down. Boy, what a loser. Wow. All right. Sorry about that. I really didn't do it on purpose. But actually, I think that's a good mistake to make because it's easy to see right there. Johnny the genius, he's got my back. Johnny, I'm so glad you called me out on that, though, because that gets really confusing. So here, let me try to redeem myself, right? So I'm going to go ahead and I'm going to keep my original mistake of writing 2x plus 3 to the power of n, right? I'm going to keep my original mistake. And this is 4 comma 3. And it was kind of flattish looking, right? It was kind of like that, right? So, Johnny, this moves x. -3, 0. That would be our vector. That would be our transformation if we wrote it as a vector. It's going to go left 3 and not up or down at all. If I go left 3 from 4, I'm going to end up at 1. Do you see? I got to go left 1, 2, 3 places. So I have to go left 3 places. So it's going to be right there, and that coordinate will be 1, 3, not 4, 0. 4, 0 is right here anyway. Wow. See, they'll let anybody teach math. All you got to do is pretend like you know it. All right. Yeah, easy mistake to make, so you just got to be careful with that. Now, so Johnny, that's how I knew that it should be there. So I had the right idea. I just got confused with my numbers and I executed it wrong, and I just wasn't thinking clearly. And I should have been more patient with it. But, okay, that's right. Now, the 2 means it's going to be, instead of being flat like that, it's going to be a little bit narrower. And so let's do that in this color, right? So it's going to be a little bit narrower. It's going to be going up twice as much, right? So that part just got moved over. Now, here's the thing. The one we were supposed to do was negative. And so one of the ways that I did these when I was learning how to do these as a student is what I would do is I would sketch like the positive, and then I would just flip it over. So like, for example, I would sketch this thing in green, and then I would go through, and this would be my answer right here. And I would do it in pencil. I wouldn't do it in green. I would do it in pencil, then go back and erase it. There we go. That makes sense to you guys? You guys doing okay with that? So yeah, that was a silly mistake. I shouldn't have made it. But hopefully if we learn something from my mistake, then it's all good, right? It's all good. We'll be okay. All right, so I think we have One more left, right? So we'll do that last one on a clean piece of paper again, right? So let's go ahead and get that set up. We'll do it on the back of this one. So we had here's our generic one, and I promise not to mess this one up, Johnny. 4-3. That's like our that's where our vertex is, or our turnaround point. It's right there, right? Kind of ugly, but well, very ugly. Not very curved over there, but we're good. Yeah, Johnny. So Johnny wants to know. Let's go back right here. Johnny wants to know on the previous question why it went down. And it went down. So it was going up when that says equals right there. When the 2 is positive, it continues to go up. But when the 2 is negative, it gets flipped over and it goes down. Right. That's right, Vanya. So we're good with that, I hope. Let's take a look at this last one right here. So, Johnny, I will be very careful with this, and I apologize for messing that one up. All right. So g of x. So now we have to take this function, which is g of x, and we have to have this transformation. Do you see? So what this is going to be, means x is going to go to the right 1, and y is going to go, y is actually going to go up 2. So our transformation vector would be 1, 2. So if I had this coordinate 4, 3, I'm going to try to be more careful here. If I had this coordinate right here, and I applied this transformation vector to it, what I'd end up with is 4 plus 1 is 5, and oops, it would be 5, and then 5. Do you see? Add 1 to 4 is 5, x is plus 1, and y is plus 2. There we go. So this coordinate is going to be, let's see if that's 4, 3, 2, 1, and let's see, that's 3. Right? So where it's going to be is 5, 4, 5, 5. It's going to be right here. So this one is going to move to the right 1 space. Yeah, to the right 1 space and up 2 spaces. I got a little confused because it didn't line up exactly with the 4 where I drew it, so I just was trying to make sure. That's why I paused right there. Okay, so this point gets moved there, and that's kind of like the flat spot. That's the turnaround. If you look, right here it's decreasing because from left to right this is going down. Here it flattens out, and the slope right here at this point right here, the slope is actually 0, and then it starts to increase, right? So that point where it changes is now moved to here. Do you understand? Okay, now only thing we got to take care of now is the 5. It's negative, so it's going to go down. So instead of going up, it's going to go down, and it's going to be quite a bit narrower. So it's going to be something like this, quite a bit narrower, and going down. There we go. That's what it would look like. Man. So I do apologize for that mistake. I hope we learned from it, and it made me actually slow down and show you another way to think about it, which I think is really a good idea, because it might give you, those of you that are a little confused by this, it might give you a new approach that you might not have thought of before, and it also ties into what we learned in about vectors and in geometry and stuff. So maybe something good came out of that. All right, last thing. Not math related, but this afternoon, the whole high school is having a meeting. And I think what we're going to be talking about is how to handle grades for school, like transcript grades, so like fourth quarter, finals, all that kind of stuff. And as soon as I know, and as soon as the game plan is in place and we're allowed to tell you, as soon as that's okay, I'll tell you. I'll let you guys know so that... I don't know. I think it's really important, especially right now with everything being kind of crazy. I think it's important to know what our game plan is and how we're doing and all that kind of stuff, okay? So, transformations of functions. That reminds me. Transformation of functions. There is... Hold on. There is... I'm going to put this in Google Classroom for you. Let me find it first. There is a question that was on a paper 4 a few years ago. I'll put it on the screen for you right now. This question caused lots of trouble. This question right here. And so that's going to be our homework for today. All right. So we're not going to have a new information this afternoon. We're going to have like a continuation of what we've been working on. So I'll put this in Google Classroom. I'll also put a link to this video in Google Classroom for you guys. But you're going to answer this right here. So we've got 1, 2, 3, 4, 5, 6 functions, right? And what you have to do is you have to figure out which of these graphs fits this. Man, that's kind of tricky. Can you imagine if you didn't have some exposure to exponential functions? Because we don't really learn exponential functions in Cambridge. But I kind of showed you with that the pennies thing and the growth of the spread of the coronavirus. So I did that like on spring break, I think. I don't know. I think I shared it with you guys. Some of you guys have commented about it. You've told me some things about it. But I'll put a link to that too, so you can kind of see how exponential functions work. And then we'll do this and we'll go over it. And we'll try to see if we can figure out like look, there's 4 answers, right? And there's 6 possibilities. So the 2 possibilities that don't fit, we'll see if we can figure out what they are tomorrow. And yeah, we'll go from there. So anyway, if you're all good, I'm all good, then we're all right. Yeah. So I guess it might be live on the YouTube channel. I don't know, Mariana. I saw an invitation for it, but I haven't looked at it yet. So what I'll do, I'll go ahead and post a link to this video and all that other stuff, and we're going to be good. Oh, Yesenia has a question about geometry quiz. It's not due. I can't, for some reason I can't go and delete all of those things in Google Classroom. Those were scheduled based on our plan when we were in school, and as they got closer, they obviously weren't there because we were going to do them in class, right? So you don't even worry about anything that's scheduled there. I'll give you whatever we're working on will just be in the chat stream or whatever it's called, right? But so don't worry about the classwork. Make sense? Oh yes, Ruben had an excellent submission for the chat for his geometry quiz. Hold on, let me find it, Ruben. I don't know where it went. Oh no, hold on. It was really good. It was really good. He sent me the meme of the day. Here we go. Hold on. Let me see. Is this the one you were talking about? I think it's great. X squared minus 1 equals 0. You have to solve it. And some people try to use the quadratic formula. Yeah, overkill. Big time. But, yeah. So anyway, is that the one you were talking about, Ruben? All right. So, yeah. All right. So we're all good. So I will post those things in Google Classroom right now. And then I guess if everybody's watching the video, then everybody's going to have the news the same. And yeah, so you guys will be good to go. So anyway, if this is confusing, we can try something else. Oh, I didn't see that. Okay, I'll check Ruben. He submitted something for the quiz. So if this is still confusing, we can try in a small group session I don't know what this means. I guess this means small group session. We can try a small group session with Google Hangouts. And you can also take pictures of whatever you're doing, whatever you had trouble with, and email it to me. But I think if you're confused, I think probably the best thing to do would be to have a small session in Google Hangouts. But I'll set that up if I get the feedback from you that you'd like to do that. All right. So anyway, I will talk to you guys later. I'll put your homework for today in Google Classroom as an announcement, and we'll be good to go. Okay. So I hope to get to see you guys in person soon. And yeah, have a good day.